Okay. So then here, done. And I'm gonna share my screen. I'll check attendance again in like about 10 minutes. Okay. So we'll start here on the blank page. So let's see. So welcome, gentlemen. This is what the start of week, I think for you all is week 6, right? So today we're going to be working on section 3.3 rules of logarithms. I did not load the full lecture early. So what I did is I went on a live stream. I did a live session with my students from earlier. And then, so the lecture is there. I think with you all, I'm going to just start in the homework and then, start there with you all. And so the recording of the full lecture is available now. Again, this is week 6, so I want you to also be aware that week 8, we're going to have exam 2, and that should cover all of chapter 3 on exponential and log functions. As always, as usual, if you have questions, comments, or concerns about things, just feel free to unmute yourself to get my attention, and we can talk about it. Otherwise, I'm going to just kind of go ahead and get started. Let's kind of make our way through the homework, and like basically what I'll do is as like things pop up, I'll take a little bit of time to give the backstory on it as best I can. So let's see. So we have section 3.3. This is on rules of logarithms. So there are these 3 techniques that we can do when it comes to evaluating logs. There are these 3 rules. The first one is called the product rule. So where you have the log of a product becomes the sum of the logs, you can break up the log of the product into one log plus another, right? The second one is going to be the quotient rule. So the log of the quotient is the same as the difference of the logs. And the last one is the power rule, where you have a power times the log. The log of a power is going to be the power times the log. So I know that's just like talk. Let's see this in action, and we'll kind of go through these. So using the log base b of 2 is this, and a log base b of 9 is this. We're asked to find log base b of 18. Okay, so let me take some notes so you can see what I mean by these rules. This one invokes the one of them. Let me get this set up here. Let's get a copy of this. Hope everyone is doing well. Let's go about here. Okay. Yeah. Let's see. All right, we're gonna drop this right here. So we have the question ID along with the full question. Okay. So this is a showcase of the product rules. This one showcases the product rule. So for instance, it asks us to find the log base b of 18, right? So let's start there. We have log base b of 18, right? So the 18 is what, 9 times 2. So this is the same as log base b of 9, or let's just say 2 times 9. Right? So the log of the product. So with the product rule says that the log of the product is going to be the same as the sum of the log. So this is equal to log base b of 2 plus log base b of 9, right? But then the instructions tells us that log base b of 2 is 0.693. Log base b of 9 is 2.197. So then we just add those together. Let's see if it's available. Okay. 0.693 plus 2.197. Okay. 2.89. What? How did it do that? Maybe it was 90. 2.89, right? And again, I'll check the attendance again in like about 5 minutes. So we got, where is it? Oh, the pencil's low. Oh. Okay, well, we got 2.89, so let me charge my pen a little bit. We're gonna go ahead and submit that result. Okay, so we got 2.89. Okay. Let me see, and just feel free to unmute yourself and stop me if anything is not clear, if you have questions. Also, I do encourage you to email me, but it's a good chance that I probably won't see the email. So if I don't respond to your email by the time we meet again, just ask me, just bring it up during class. Ask me at the end of that session. Or, we can take time during classes. Again, the intent of class time is really a Q&A. It's really intended to be like a study session. But, me trying to get students to speak is like pulling teeth. So instead of doing that, I just feel it with like going through the homework. But you still got to do it yourself because you're going to have the same questions as me on the homework, but then the numbers are going to change, right? So you can always use this, like these sessions that we have, because they're recorded, you can use them, like when you're going through, use it as like a base or something. But so you have the resources, you just got to take your time and get it done. Given that log base b of 3 is this, and log base b of 4 is this, and log base b of 7 is this, we're asked to find, okay, that's fine, log base b of 4 over b. Okay. Let's take some notes here. Hopefully my pen is charging enough. Okay. Man, like my remote streaming has come a long way. In the past, it was so hard to like do a screenshot. It was like lagging so much. This is actually way better than what it used to be. I don't know what that would be for me. All right. And like was before, I was like using OBS and like sharing my screen of my tablet to the computer. Now I just use the tablet. Like I decided at the start of this semester, I was like, okay, let's try to get it on one device. And I tried it and it worked. I was like, oh, okay. So we're asked to find log base b of 4 over b. All right. Okay. So this is showcasing what's called the quotient rule. The product rule was the first one. This is the second rule, which is called the quotient rule. So the log of the quotient is the same as the difference of the logs, right? So this is the same as log base b of 4 minus log base b of b, right? That's the quotient rule. Right? The instructions gave us that log base b of 4 is 1.153 minus log base b of b. This is 1. Right? So then that result is going to be 0.153. Okay, copy. Again, all these things that you see me writing, the notes, the lectures, even the lecture, the blank set of lecture notes and the handwritten set of lecture notes, copies of both of those documents, all of the stuff that you see me writing is on our Blackboard. And I think it's link number 2, where it's like the box link or whatever. 0.153. Let's here. 0.153. Let's see. That is it. Okay, what's the time? Sure, let's go ahead and check it now. It's a little bit earlier. Let's do one more question. Give it another minute. Given that, let's do the same thing. It says evaluate without using a calculator. That's fine. So let's get a copy. So this actually combines the product rule with that third rule of the power rule, right? Let's go like this. So I'm working on my iPad, but it's been trippy. Like it's just not responsive. And so it's frustrating because I'll be gaming and then I go to move and I had to like click the button on the tablet like 12 times before the player moves. And I'll be like, come on. It's so frustrating. And like I've seen where they have the bone thing for the phone. I don't know if they have the bone thing for the tablet. Like so you can like actually have buttons instead of trying to touch the touch screen. Because the touch screen don't work in the heat of battle. Like not the way it should. Okay. So we have this log of this product and all of this stuff. Let's see. So we have two rules that are at play here. We have the product rule and the power rule. So with the product rule, the log of a product can be rewritten as the sum of the logs. So let's do that one first. So then this is going to be the log of 2 plus the log of x squared plus the log of y. All right. Okay. So then this middle term showcases the third rule. The log of a power is going to be the same as the power times the log. Let's do that one more time. The log of a power is the same as the power times the log. Okay. So then this is going to be log of 2 plus 2 times the log of x plus the log of y. Right? The instructions say that the log of 2 is 0.3 plus 2 times the log of x is 3 and the log of y is 5. So 6 plus 5 is 11. This ultimately is going to be 11.3. Okay. Let's see, how do we do? Okay, I'm going to share something. I'm just sharing it because I don't think I'm really supposed to create this thing. This is a tangent. This is a random thought that I had, but I think it's a really good idea, and I just want to see it come to life. Whoever is the first to create this is going to be, it's something like revolutionary. I don't know that I'm going to create it, but I want it to exist. So I'm speaking it into existence. This is a tangent. So adulting is hard, right? You got so many bills, you got to pay this and that and feed yourself and this and that. And it's like, it's just a lot of random small things, right? So I was thinking to myself, I was like, so it would be nice if there was like a place where you pay like maybe once a year or once every 5 years or 10 years or whatever, and everything is taken care of. I mean, you have a place to stay with your utilities, you have food, maintenance, like you just make a one-time payment and you don't have to think about it for X amount of time or whatever, however much time you pay for. And honestly, if it was really up to me, I really wouldn't charge people. Like I would not charge people because you don't have to. Like if it's like a cruise ship, but you're on land, all right? And like, cause we have resources, we have technology, we have everything. The only reason it doesn't exist is because nobody's building it. And like the people in power are like actively shutting people down, right? But I know in this society, people don't value things unless you associate money to it, right? So then I was like, well, I would charge them then, only because they say they need to be charged. But if it were up to me, I wouldn't charge anybody. Like, okay, what do you need? Let's get you set up. And then these are the rules or whatever. And then, and it would be minimal rules, just don't be destructive, like is the main thing. So I think it's a fantastic idea. I just want to see it exist and I just want to see as many people taken care of. If it's not me that does it directly, I'm going to put the thought in somebody's mind, somebody's going to create it. I feel like I have what I need. Like, I mean, obviously I need more stuff, but I'm indifferent about it, to be honest. I just want to see people taken care of, right? So that's my challenge. That's my charge to somebody. I'm using my platform, this thing, at least I have you guys' attention, whoever's listening. I'm just putting it out there to somebody's mind, and I just want to see it exist. And if I figure out how to do it myself, I will. But I don't see me doing it, but I can see it in existence. So that was my little tangent. It's basically like, all expenses paid for like however much time. And I think that would make life so much easier. Now, obviously you would need like you would need like maintenance and workers and management and all this other kind of stuff. But you can work stuff out. You can work it out to where basically it's a community and people are taking care of each other, and they have this time to do whatever it is they want to do, as long as they want to do it. I think it's fantastic. I know I would sign up. So that's my little tangent. Again, it would be nice to capitalize on it, but I'm indifferent. I know how to will and deal. I just want to see people taken care of. Okay. So it's out there. I put it out there, and I'm going to keep putting it out there until I see it, or until I create it, whichever comes first. So with this one, getting back on task, I think we got 6 plus 5 is 11.3. Okay. Type of integer or decimal. Let's go with 11.3. Because Lord knows I have a ton of ideas like to create. Anyway. And like, honestly, I've been thinking about like starting a club. Like, for instance, my nephew just bought a 3D printer. I was like, man, I had intention of buying a 3D printer for the longest. And like, honestly, with 3D printers, you can make anything that you want, like anything. Like one guy has a 3D printer. He kept making phone cases, and the phone companies contacted him. I was like, hey, will you stop making phone cases? You're cutting entire profits, right? It's like this. I'm telling you, the technology exists to make whatever you want. I've seen where people use 3D printers to print entire houses. And there's a couple of ways that you can do it. I think the fastest way is they have a giant 3D printer, and it actually prints the whole house. It takes like a few hours or whatever. But then you could also print like each individual piece, as long as you have the resin or whatever, you can print it and build anything. You can just make the different pieces and build it. You can try different structures. Like, I'm telling you, like, that's the kind of stuff I'm about to start making. As soon as I like get myself squared away where I'm like outside that system of money, it's going to explode. I'm going to make a Wakanda for real. Like, and if I don't make it, I'm going to set somebody up to make it. And then I'm going to come back and live in the Wakanda. That's exactly what I'm going to do. Anyway, just going on flights of fancy. So let's see, write the following expression in expanded form. Okay, this one's not bad, right? So this one is the product rule. Now, this one's kind of a little trick, right? Where it's, you might be tempted to see, oh, you see the difference of the logs? There's no difference, right? So where you see the log of the x minus 8, you can't break that apart. But you can break apart multiplication, division, and powers, right? So then this one is going to be the natural log of x plus the natural log of x minus 8, right? Okay. On to the next one. Oh, I think I did say I was gonna, let me go check attendance real quick. Let me go check Zoom again, because I did say I was gonna do that. Okay, we still got some people hanging in there strong. Okay, let me get these guys. So that means, okay, that's fine. Let's go to edit. And let's stop this for the time being. Okay. This one. Okay, I think I got him, maybe CD. Okay. 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 Let's get this other student. All right, all right, gentlemen, welcome. Let me hit save so I don't lose my work. Record attendance today. Right here. Next, okay. I think that's good. Let's go back to sharing the screen. We are still streaming. Start. Come on. And then back here. Okay. So it says use the properties of logs to expand the logarithm as much as possible. Evaluate the log expression without using a calculator. Okay, so I think they want the evaluate it. We can evaluate this if possible. Okay. So we're going to go ahead and expand it. So again, the 3 rules. The first rule is the product rule. the log of a product can be broken in, is going to be the same as the log of the sums. So you could take the log of a product and break into the log of the first product, plus the log of the second product. The quotient rule says the log of the quotient is the same as the difference of the logs, and the power rule says the log of the power is the same as the power times the log. Okay, so the main operation here is the quotient, right? So we can say the top minus the bottom, but then the top is a product, so that can be broken apart into the log of the first part plus the log of the second part. Okay, and then we have to apply the power rule, right? So I'm gonna kind of do this in one go. We have 3, thank you. We have 3 times the natural log of x. And again, if anything is not clear, you have to catch my attention and stop me and we can talk about it. Then we have 1/2. Let's see, times the natural log. We got this x squared plus 5. And then we have minus the natural log of, and then we got 5 because of that power of 5. Natural log of x plus 5. Okay, again, just if anything isn't clear, you have to get my attention. Okay, let's see how do we do. Okay. Let's do another question. So this seems like a fairly short question. Set of homework. Write the following expression in expanded form. Okay. So then the 2 would be in front. So it can't be A, it could be B. Here, let's zoom out so we can see better. Okay, that might be a little bit far. Let's zoom back in better. Okay. Let's see. So it can't be A because when you apply the power rule on the numerator, the 2 would be in the front. So it should be either B or D. 2 times the natural log of the numerator minus, so then it can't be D, right? Because the minus is in the wrong place for D. And then they didn't distribute the minus in part D properly. So then we're gonna go with B. Okay, let's go with it. Write the sum as a log of a single expression. So basically, so what this one is working backwards. So we worked on a few examples where we expanded logs. So given a log, we expanded it applying the rules of logarithms. Now what we're going to do is starting with the expanded form, we're going to work backwards and finish with the condensed form, right? So when you have the same base, the sum of the logs is the reverse. We can reverse that on it's going to be, if you have the log of the product is the same as the sum of the logs, then if you start with the sum of the logs, that's going to be the same as the log of the product, right? Okay. I know that was a mouthful, but we can zoom in just a little bit. Oops. Oh, maybe that's why that messes up because I'm too zoomed in. Okay. So working backwards is going to become log base 3 of 4z. Let's type it like this, 4z. Okay. Again, we're condensing it, so we're working backwards. So then we're going to have the natural log. Now that 3 can go to the exponent of b, so we're going to have ab cubed c to the power 5. So the sum of the logs becomes the log of the product. Use a change of base, right? So the change of base, like, okay, notice like with this example, if you try to evaluate this in most calculators, like a scientific calculator, a scientific calculator has common log. Common log is base 10, right? So what if we wanted to crunch a number that has a different base? So then that's where this technique of the change of base formula comes into play. Change of base basically says that this log that you see on the screen right now is the same as the log of 10 divided by the log of 4. You can also do it as the natural log of 10 divided by the natural log of 4. You get the same result. Do not round logarithms and the change of base. Do not round to 10 to the 5, then round to 4 decimal places. So first, I'm gonna do the natural log one just to show you that it works. The natural log of 10 divided by the natural log of 4. Round to 4 decimal places, 6610. Yeah, 6610. 1.6610. That's right. 1.6610. Use a calculator and a change of base formula to find the log to 4 decimal places. So again, calculator is normally base 10. So if we want to evaluate a log like this in the calculator, we have to use a change of base. Come on. What's there? Yeah, that's okay. Let's pull this out. So then change of base goes the log of 2 divided by the log of 1 by 10. Four decimal places, negative 0.3010, so just 301. Okay. Use the change of base formula to approximate. Okay, so I'm just gonna use my calculator again. So last time we did change of base with natural, this one we did log. The first one we did the change of base with natural log, and then we did it again with common log, right? It's the same. Right? So this is gonna be the same as the log of 9 divided by the log, and you just need to be consistent, divided by the log of 4 plus the log of 3 divided by the log of 4. Yeah, that's right. So there's 100,000, so 3 decimal places. So 2.377. 2.377. Okay. Simplify, okay. So this is like the power rule. Let me think about it. So the 9th root of b is the same as b to the power of 1 over 9. So this is going to be the same as 1 over 9 times the log base b of b. Oh, okay. So if we have log base b of b, that's actually 1. So then this is really just 1 by 9. Okay. Find the value of the function without using the calculator. Okay, let's take some notes. So I totally just got sleepy like all of a sudden. I was like, oh, I want to go to sleep now. I just want to go like, and I would go into a deep sleep. So we only have about 10 minutes. All right. So let's take some notes on this one and let's take a look at it right here. Okay. I don't know if you guys watched the Daily Show with Trevor Noah. I enjoy that show. It's just fun. Not last night, but night before last, he interviewed India Arie. I thought it was a good interview. It's on YouTube as well. Okay. So with something like this, what I'm going to do, let's start by setting this. Let me see, will that help? I think it will. Start by setting it equal to y. And then we're going to rewrite this exponential as a log, right? So if we rewrite this exponential as a log, the 7 of the base of the exponent, when it swings to the other side, is going to become the base of our log. So then that'll give us, well, okay, let's just write it. 2 log base 7 of 4 plus log base 7 of 2 equals log base 7 of y, right? So then we can apply the power rule in reverse, right? So the log of a power is the power times the log. So if we reverse that, the power times the log is going to be the log of the power. So that 2 can move up to the exponent. So then 4 squared is what, 16? And then the sum of the logs becomes the log of the product. So 16 times 2 is 32. So this is really log base 7 of 32 equals log base 7 of y. So then y has to equal 32. This is true if and only if, I think that's how that goes, y equals 32. Okay. So then we just get 32. So I was watching Frozen 2, and it's just like, it's so, the songs are so stuck in my head. Now, what do we get? 32? Okay, let's try 32. Cool. Let me see the time. Okay, we're almost there. Next question. How many? Question 13. We've gone through most of these. I kind of went a little bit faster now what I've liked. I think I'm gonna just go ahead and let this be the last one. Find an equation of this form whose graph contains 2 given points. Yeah, this is gonna be the last one. This one takes a few minutes, and then we might have a short session on Friday, maybe. It just depends. We'll see how it goes. Okay. All right. Oh, just barely got it. Okay. Okay. So we worked an example like this with my students earlier. The book, if this one pops up again, I'll do it the way the book did it, but I'm gonna do it with you all the way I did it with my students earlier, right? So the first thing we did was we plugged in each X and the corresponding Y into the model, right? So I'm gonna reverse the order as well. I'm gonna put the Y on the right hand side. So we don't know C yet. B plus B times the log base 8. Now when X is 2, our Y value is 1, right? Then we're gonna have C plus B log base A. Now when X is 4, the corresponding Y is 6. Okay. So then what I did, I used a substitution technique where, like for instance, I solved for C from the first one. Okay. So basically if we subtract the B log base A of 2 from both sides, I'm going to just put it over here to the side. We get that C equals 1 minus B log base A of 2. Right? So we just get the C by itself. Then what we're going to do is take this C and plug it into the other equation. So then that's going to give us 1 minus B log base A of 2 plus B log base A of 4 equals 6, right? So we have, this is like really let me subtract 1 from both sides and rearrange these two guys. I just want the middle I want the subtraction sign to be between these two guys. I'm just switching them around. And also I'm subtracting 1 from both sides of the equal sign. Okay. So then if we do this, we're gonna have, and I'm gonna do one other thing. Go ahead and use the power rule where I'm gonna move these b's to the exponent. I know there's a lot of arrows. Here, let me do this so I can make a distinction. I'm gonna move this b to the exponent, this b to the exponent. Okay. So then if we account for those changes, we're gonna have log base a of 4 to the power of b minus log base a of 2 to the power of b equals 5. Okay. So then the log of the difference is the quotient of the logs. So then on the left, we're going to have log base a of 2 to the power of b equals 5. And then we're going to rewrite this log as an exponential by swinging the base of the log, and it's going to become the base of the exponent. And this is going to give us 2 to the power of b equals a to the power of 5. So then from this, we get that a equals 2 and b equals 5, and we need to go back and solve for c. So then earlier, we said that c equals this. So we're going to have 1 minus, now our b we got was 5. So 5 times the log, our base we got was 2. So log base 2 of 2. This guy is 1. It collapses to 1. So then 1 minus 5 is negative 4. So then we get c equals negative 4 right here. Okay. So then if that's our A, B, and C, C plus B log base A. So then if we apply it to the model, C plus B log base A of X equals Y. And I'm just going to switch them around. Long story short, the model that we get is Y equals negative 4 plus 5 times the log base 2 of X. Okay. So then we can check. Yeah, we didn't. I thought we were gonna get out a little bit earlier. Style. So we can check this before we submit it. All right. We want to make sure that this works for the given points. Okay. So what I'm going to do is go to my y equals, and I'm going to type in the model that we just found, negative 5. Oops. C is negative 4. See, I told you I'm sleeping. Let me make that change. Gotta make that change. Negative 4 plus 5 log base 2 of X, okay? This is gonna be, okay. Negative 4 plus 5 times the log of X, but we gotta account for that base of 2, so we're gonna say divided by the log of 2, change of base form. Okay, I'm gonna hit enter. So then I'm gonna go back to the home screen and I'm gonna call in that function. Left of the clear button is variables. I'm gonna go to the right to go to Y variables, number 1 for the function, to access the function menu, and then number 1 again to call in the function that we just typed in. So now, when X is what, 2, the answer should be 1. And when X is 4, the answer should be 6, okay? So then want to take that result. Okay. So let's give it a go. So we got -4 plus 5. Oops. Plus 5 times the log base 2 of x. Okay, and check this. Okay, so thank you. Let me go ahead and share a copy of these notes that we were working on together with you all. Send it to the box. Okay, I think that's fine. Okay, I can't think of anything else. If there aren't any burning questions, we're going to end the session here and we'll pick this back up on Friday. And for one beautiful mind to another, enjoy the rest of your day. All right, guys, take care. Peace.